Okay, so we're going to continue our investigation into derivatives here and basically how to find derivatives of different types of functions. So let's start with a little bit of review. Let's say I start with this function x cubed minus 2x as we see on the left. The derivative of x cubed minus 2x, right, would be that f prime equals 3x squared minus 2. That should be pretty straightforward. The method we used was the power rule. And the question is, well, why did we use the power rule here and not something else? Well, because we only have one term, raised to a power at a time. Raised to a power at a time. Okay. However, if I asked for the derivative of x sine of x, we would have to use the product rule in that case, and our derivative would be g prime of x equals x cosine of x, so leave the first one the same, multiplied times the derivative of the second, plus take the derivative of the first, the derivative of x is 1, times the second function, sine of x. That's the product rule, as you know. And why do we do that? Because we had two functions being multiplied together. Okay, so those we also know the quotient rule. We know the derivative of trig functions. We've learned a lot of different ways to take derivatives. One of the ones we haven't talked about yet, that we're going to learn today, is how to take the derivative of something where there's a function inside a function. So if I take a look at this, sine of x squared, I see two functions. I see the squared. I'm squaring something. What am I squaring? I'm not squaring x. I'm squaring a separate function, sine of x. So I basically have two functions, I have basically a composite set of functions here where I have one function inside another. Oops. So my derivative on this one, I'll just go ahead and tell you, then we'll talk about why if that's the case. My derivative, in this case c prime of x, would be 2 sine of x cosine of x. Okay, and the way I figured this out was a method called the chain rule. C-H-A-I-N, the chain rule. And why was I allowed to use the chain rule? I have a composition of functions. So when I have a function inside another, I'm going to use this thing called the chain rule. All right. So let's take a minute to think about this. A little intuition behind the madness here. So why am I getting 2 sine of cosine of x for the derivative of sine of x squared? Well, let's use our notation here. If I take the derivative of sine of x squared with respect to x, I'm telling you that we should get 2 sine of x times cosine of x. Again, that thing that goes on the top next to the d is just your function. So in this case, my whole function is sine of x squared, so that's what I put there. Usually we define a function as y, which is why you say dy dx. But then in this case, it's just d sine of x squared over dx. Well, take a look. What do you think I did to get the 2 sine of x piece? What do you think I did here? It looks like I just performed the power rule on sine of x. I brought that 2 down in front and did the power rule just on the sine of x, leaving sine of x the same. In reality, what I just did was I took the derivative of sine of x squared, not with respect to x, I did it with respect to sine of x. So what I really mean by that, or how you could think about it, is that bottom piece, think about it as what you perform the power rule on. What you perform the power rule on. Okay? So basically I perform the power rule on sine of x. Normally, if it was x squared, you would have 2x. But in this case, I have sine of x squared, so I have 2 sine of x. So the way you would notate that is the derivative of sine of x squared over d sine of x. Well, how do you think I got the cosine piece? How did I get cosine? That right there. Well, cosine is just the derivative of sine. So it looks like I probably just took the derivative, okay, of sine of x with respect to x. Okay, now think about that for a second. The first piece, the 2 sine of x, was the derivative of sine of x squared with respect to sine of x, so I performed the power rule on the sine of x. And then I took the derivative of sine of x with respect to x, kind of like we normally would do. Well, look what happens. Again, this was all being multiplied together, right? 2 sine of x times cosine of x, so it makes sense I would multiply those two notations together. What happens to those d sine of x's? They actually, believe it or not, cancel out. And what am I left with? I'm left with d sine of x squared over dx. So the derivative of sine of x squared with respect to x. Okay, so hopefully that makes sense a little bit. If you're like, what are you talking about? The good news is this is just some intuition why. I'm going to give you the no-nonsense, non-confusing, plain old English definition of the chain rule right here, okay? So, to find the derivative using the chain rule, okay, the derivative is equal to the derivative of the outside. We're going to leave the inside the same. So the derivative of the outside, that's basically me taking the derivative of the sine of x squared, doing the 2 sine of x. So derivative of the outside, 2 sine of x, where I left the inside the same. So I left sine of x the same, times, okay, times the derivative of the inside. So that's the derivative of sine of x. That got me cosine of x. So that top piece is the blue above, and the bottom piece, the derivative of the inside, is the yellow piece from above. Okay? That is the chain rule. In and of itself, it's pretty simple. What makes it complicated is not always understanding or recognizing when to use it. And as we get into some harder examples and we get into other derivatives going forward, you may not see, the chain rule may not be obvious. Okay, but right now, hopefully the actual mechanics of it aren't too tricky. So let's run through a few examples together, and then I'm going to let you go. So let's start with the problem like the second one, y equals 7 minus 4x squared, all raised to the 2/3. This is on the next page, so the back of the first page here. So let's take the derivative of this. This is a chain rule problem, and I know it's a chain rule because I have this 2/3. And then inside that 2/3, I have that whole 7 minus 4x squared, another function other than x. So that tells me it's a chain rule problem. And what I'm going to do is take the derivative of the outside, leaving the inside the same. So dy over dx equals 2/3, 7 minus 4x squared, all to the negative 1/3, times, okay, the derivative of the inside. The derivative of the inside would be negative 8x. And that's my derivative. Okay? Now in a problem like the one below it, negative 3 over x cubed minus x squared plus 3 cubed, you have two ways of doing this. You can jump right into the quotient rule, or I'm just going to show you an alternative way of doing this. We could rewrite this equation as y equals negative 3 times x cubed minus x squared plus 3 to the negative 3, and just use a simple power rule on that. So let's do that, or power rule within the chain rule, excuse me. We would say dy dx equals positive 9, so negative 3 times negative 3 is positive 9, times x cubed minus x squared plus 3 to the negative 4 times the derivative of that inside, 3x squared minus 2x. Okay? If you wanted to use the quotient rule, you could have. It gets a little bit more complicated. But it's up to you. Totally your call. All right, let's go on to the next type of problem you might see is chain rule with root functions. So let's take a look at the second one, y equals negative 5, x squared minus 4x plus 1, all under that root. First thing I'm going to do is rewrite it so that I actually have some exponents. So negative 5 times x squared minus 4x plus 1, all to the 1/2. Now I'm going to use the chain rule on this. So dy dx equals negative 5 over 2 x squared minus 4x plus 1 to the negative 1/2 times the derivative of the inside, which is 2x minus 4. All right, the one below it, why don't you take a second, pause the video, and see if you can come up with the derivative for that. My advice, I'm going to do it where I bring that root to the numerator and do a product rule. But it's up to you. If you want to do quotient rule, you can do the quotient rule. I'm going to make it so that it's a product rule. All right, so hopefully you paused it and had a chance to work through it. I'm going to run through the answer now. So first things first, let's change it to something with an exponent in it. So if y equals x squared minus 1 to the negative 1/2, all times that x out front, dy dx equals, don't forget we have the product rule, so I'm going to multiply it times the derivative of x times the original function, so it's 1 times x squared minus 1 to the negative 1/2 plus x times, now this is where you have to be careful, okay, times negative 1/2 x squared minus 1 to the negative 3/2 times 2x. Okay, so be careful with a problem like that. Hopefully you got it. Let's keep on moving. Chain rule with trig functions. Ah, this is good. Let's try the negative 2 cosine of x squared plus 2. And if you want to pause the video, if you want to give it a shot, feel free to do so. If you want to walk through this one with me, feel free to do that as well. So we get dy dx equals the outside function's the cosine. So the derivative of cosine is sine, negative sine. So we'd get positive 2 sine of x squared plus 2 times the derivative of the inside, which is 2x. Let's try the one below it, y equals sine of 1 over x. I would encourage you to pause the video and see if you can come up with an answer for that one. All right, this is a little bit tricky. Hopefully you gave it a shot, but I'm going to rewrite this first as y equals sine of x to the negative 1, so I can do the power rule on it. And then the dy, or the derivative, dy dx, derivative of sine is cosine, so I have cosine of x to the negative 1 times negative x to the negative 2. That's the derivative of x to the negative 1. All right, let's scroll down to chain rule with exponential functions. Let's take a look at that second one, y equals e to the sine of x. If I take the derivative, I get dy over dx. I'm going to take the derivative of the outside, leave the inside the same. If you remember, the derivative of e to the x is just e to the x. So I'm going to have e to the sine of x times the derivative of the inside, or the exponent, which in this case is cosine of x. All right, try the one below it. This one's tricky because there actually might be 3 functions inside here. So take a second, think about it, and then unpause it or play it, and we can walk through the solutions together. All right, so hopefully you did that. My dy dx would be e to the cosine of 3x plus 2, so the derivative of the inside, or excuse me, the outside, which is the e function, times the derivative of the next inside piece, so that's cosine, so the derivative of cosine is sine, leave the inside the same, times the derivative of the next inside piece, the derivative of 3x plus 2, is just 3. All right, last one. Let's go into chain rule with logarithmic functions. Okay, so we have y equals cosine of ln of 4x cubed. This is the second one. Let's try to run through this together. So we get dy over dx. I'm going to take the derivative of the outside function, that's cosine. So we get sine of ln of 4x cubed times the derivative of ln. If you remember, the derivative of ln is 1 over x. So it's going to be times the derivative of 1 over 4x cubed. I'm going to leave whatever's on the inside of ln the same, times the derivative of the most inside piece. Derivative of 4x cubed is 12x squared. All right, why don't you try the one beneath it, hit pause, see if you can figure it out, and then hit play, and then we'll see if our answers match. All right, on this one, looks like we have a product rule going on. So dy dx, I'm going to take the derivative of the first piece. That's going to be 1 over 4x squared times 8x times that second piece, unchanged, plus the derivative, the first piece, which is ln of 4x squared, times the derivative of the other piece. That's going to be negative 3x squared. So then we get 1 over 4x squared times 8x times negative x cubed minus 4 plus ln of 4x squared times negative 3x squared. Okay, and the last one we'll look at is chain rule with tables. Let's go down a little bit. It says, given the following information, find the value of the derivative of the functions at x equals 3. Be careful, not all the information given is needed to calculate these. Answers are next to the problem. All right, so let's try the second one, f of x squared. Well, the first thing I want to do is list out what the derivative might be. So I have 2 things. I have the derivative. Now I notice it doesn't give you anything here, so we'll just call it d of f of x squared over dx. That would equal the outside function, derivative of the outside function, which would be 2f of x, times the derivative of the inside function, which would be f prime of x. I would want you to write that out. So write it out using notation and then fill in the numbers after. So then if I want to know what this is, derivative of f of x squared with respect to x at, what are we doing? It's x equals 3. That would be 2 times f of 3 times f prime of 3, which equals f of 3 is 1. So 2 times 1 is 2. Times f prime of 3. F prime of 3 is negative 3. So I get negative 6 as my answer. Okay? So that's chain rule. I know that was kind of fast. We're running on 20 minutes here. I don't want to make the video too long. Your homework or classwork, which you should be able to get done in class, I'm going to circle them in red. We'll do a couple from each section. Again, the answers are on Canvas, so please check it. So let's do this. Let's do that guy. We'll do an easy one, and then we'll do a little bit of a harder one. So those two from the first section. From section 2, we'll do an easy one, and we'll do a harder one. From the third section, let's do a couple harder ones. Let's do cos of tan and cos squared 5x squared. From the fourth section, let's do an easier one. Let's do that guy, and let's do that guy. The bottom one here, okay, you may want to simplify expression before you take the derivative. I'll let you kind of figure out what that is. But simplify expression, or change the form, I should say, before taking derivative. Derivative. Okay, spell. You may want to change that form first. Think about maybe moving that e up to the exponent, or excuse me, up to the numerator. Might make it easier. Logarithmic functions. Let's do that guy and that guy. And for chain rule with tables, we already did f that one. So let's do g of x and the root f plus g. Okay, so those 10 problems, or 12, whatever it was, I circled in red, we'll do for classwork. I think you should be able to get it done during this class, in which case you'll have no homework tonight. All right, good luck with all that, and I'll talk to you guys soon.